Hey guys, welcome to quadratic formula video number 2. Hope to be able to answer any questions that you might have a little bit after this. I'll start off with the joke of the day. What kind of doctor was Dr. Pepper? He was a physician. All right, so when you start doing quadratics, you're going to get a number underneath the radical. Okay, we have the formula here, and you'll see there's a radical b squared minus 4ac. First off, if that number underneath there is negative, that means there's no real answers. Okay, it's an imaginary, meaning it's not going to cross the x-axis. Number two, if it comes out to be something like a 36 or a 49, those are perfect squares. So you could pull it out as a 6. Those are called rational. Well, we have some irrational numbers, and that's when it's a non-perfect square. So in this case, you're going to take a look at the number and try and find out, well, what goes into 8? And you need to find another perfect square. So you got to go under 8 and think of some perfect squares besides 1. And in this case, you would find something like 4 times 2. And 4 times 2 is nice because 4 is a perfect square. What is the square root of 4? It's 2. So when you take it out of the square root, it just becomes 2. And this guy stays 2. So it becomes 2 radical 2. Hopefully that helps. Number 2, letter B. Well, 45. Well, you could do 9 times 5. I wouldn't do 15 times 3. And the reason why I wouldn't do 15 times 3 is neither 15 nor 3 is a perfect square, but 9 becomes 3. So my answer is 3 radical 5. And the next one, 48. Well, you could try different numbers like 8 times 6, not perfect squares. You might even try 12 times 4. Well, 4 is a perfect square, but 12 can be broken down with another 4, so you didn't pick something high enough. Now, if you're not sure, this is a cheat method. You can go to your calculator and put in 48, y equals, 48 divided by x squared, the number divided by x squared. When you do that, you hit second graph, it'll come up with the answer for you. And the best answer is this guy right here, which is 4 radical 3. Okay, 4, 3 would be 4 radical 3. Now, if you just put in 48 divided by x instead of x squared, well, then it's going to give you, well, what numbers do you have? Now, you can get the answer from this, but you'd have to play around a little bit. So I would see 2 and 24 probably not big enough, 4, 12. And I would have to go down as far as I can till this gets closer to 0. And I see 16, 3. And then that's it. 24, 2. 24 and 2 works, but then I wouldn't be able to break it down. So that's why I like the x squared. I know that it's going to turn into be 4 radical 3. All right, let's get back to where we were. So I know this is 16 times 3, which becomes 4 radical 3. All right, so if I know the answer is 4 radical 3, I can go backwards. 75, well, that's quarters, but there's a negative sign. So I'm going to use quarters. How many? 3. And what does the 25 become? Becomes 5. Not radical 5, it becomes 5. So I'm going to write negative 5 radical 3. And why negative? Because the negative is on the outside. It's okay to have the negative on the outside. I'm not sure if you could see that negative in letter D and letter F. 72, I'm going to divide by 2. Oh, yeah, divide by 2. 36. 36 becomes 6. And I write 6 radical 2. 500, I'm going to use 100 times 5. And what is 100 times 5? 500. Good. Let's keep the negative. So 100 becomes 10, negative 10, radical 5. All right, I'm available Friday in case you guys have questions. Now, the question I have for you is this one. Once you get it in the right form and you say, whoa, A is 5 and B is 6 and C is 10, you then have to use the quadratic formula. Okay, first question I'm going to give you is this one. X squared plus 12x plus 24. So I know that my A is 1, and my B is 12, and my C is 24. Now, I did this elsewhere, so I'm just going to show you how I did it, and you can copy it down in your own form, but I like the little template. So here we go. Let's go find x squared plus 12x plus 24. Let's go find that problem. And that would be right here. Okay. So as I said, I have a 1, a 12, and a 24. So every time I see in this first spot, the B's, these are my B's right here. I'm going to put a 12. B, I put a 12. A, C, B. If you're not sure where I got that from, I got it from right there. Negative B plus or minus B squared minus 4AC all over 2A. That's something you don't have to memorize. It'll be written down for you. Okay? What do you do next? Well, you make this into negative 12. And then you could do all this in your calculator, or you could do it in 2 steps. So let's say you skip this step right here. If you just put all this in your calculator, you get 144 minus whatever, and that would come out to be 48. So let's just say you skipped, you might skip this step in here. Let's say you skip that step, and you got 48 all over 2. All right? So when you get 48, what you need to realize is it's not a perfect square. 49 is, but 48 is not. So what you then need to do is find what numbers would go into 48. So what I did is I wrote them over here, and you wouldn't normally do it this way. But you can say that 48 is 16 times 3. Now, which one of those is going to come out? Well, this one is. The 16 is going to come out as a 4. So what I'm going to do is instead of using 48, I'm going to use 16 and 3. And then I'm going to pull the 16 out as a 4. So that's where I got this 4 from. So it's really 4 times radical 3, because that's really radical 16. And this is just 2 on the bottom. Okay, now you think you're done. You have negative 12 plus or minus 4 radical 3 over 2. You could be. But do you see the little heart I drew? If the 3 numbers outside the radical, the first number before the plus, the number after the plus, and the number on the bottom, if they all go into each other, you can divide them, but only if all 3. You cannot go any further if not all 3. So I know that 2 goes into all of them. So when I cut this guy in half here, I get negative 6. When I cut this guy in half here, I get positive 2. And when I cut this in half, I get 1. So I got rid of my denominator. So in reality, my answer is negative 6 plus or minus 4 radical 3. Ooh, I messed up somewhere. What did I do here? Oh, no. Sorry, 2 radical 3, because this, when I divide it, what I was trying to show you is I divided all these by 2. How come? Because they can be divided by 2. So when I divide them all by 2, I get that. You don't divide the radical 3 by 2. So my answer is just negative 6 plus or minus 2 radical 3, which really is negative 6 plus 2 radical 3 and negative 6 minus 2 radical 3. That's about as hard as it's going to get. I just wanted to show you this on a new video, and we'll go over a couple more questions on the other sheet. That's it. Let's go back to the other sheet. So what do we get? X equals negative 6 plus or minus 2 radical 3 was the answer. Those are 2 answers. All right. And they're not nice answers. They're like maybe negative 2.6 and positive 2.6. But it's not exactly. It's like 0.66347821. All right. So let's take a look at some of these problems. We already did 48. We said that 48 is 16 times 3. And then that 16 becomes a 4. All right. And you can see this one here. They used 81 times 2 is 162. And then the square root of 81 is 9. So I'm going to pick a couple. Let's do C. First off, don't lose the negative sign. What number times itself is going to give, what 2 numbers times themselves is going to give me 90? And one of them has to be one of your perfect squares. If you chose 45 and 2, not correct, because 45 is not a perfect square. that doesn't work. If you tried some other numbers like 30 and 3, also not good. Your best bet is a perfect square of 9 and 10. 9 goes first because he's the perfect square. That becomes a 3. So you get -3 radical 10. Okay, and then you could try a couple on your own. I'll try this one here with you, which is 100 times 3. And then the 100 does not become 50. It becomes a 10. 10 radical 3. Or you could try B and E by yourself. And I'll try and give you guys maybe a problem or two on your own to do later. If you have questions, ask to meet with me or use my hours where I am at Google Meet. Take care.